Okay, so this was the application we did in the last session. Today we look into the data types available with the Java. Okay, Java data types. Very first thing in the Java data types is every type it inherits from the object. Okay, this is the root type or root object for all the types of data. Every type inherits from the object. In Java, every type inherits from the object. Further in the types, we have value type, and next thing is reference type. There are two different types of data. One is value type, other one is reference type. Okay. Further in the value type, we have like this is numeric, char, boolean. These are like value types. They are nothing but primitive types of data. Similarly, we have here enum. This is a user-defined value type. Okay, you have numeric, char, boolean, and enum. These four different types of data belong to enum. Okay, you have numeric, then you have character, boolean, and enum. In the numeric, further you have first thing is like here it is byte, then short, int, then long. These are the four integer types: byte, short, int, long. Okay, the size of the byte here it is 1 byte. The short size is here 2 bytes. Int is long 4 bytes. Similarly, long is 8 bytes. Okay, so in the numeric type, first of all, we have integer types: byte, short, int, long. Byte is just 1 byte, short is 2 bytes, int is 4 bytes, long is 8 bytes. Okay, so the sizes for them. So byte requires 1 byte of space, short requires 2 bytes of space, int requires 4 bytes of space, and long requires 8 bytes of space. So in Java, the type system is very simple. Okay, if you look at numeric types, particularly if you look at integers, everything is actually a signed integer. There is no concept like unsigned as far as Java is concerned. We don't have any like unsigned integer concept in this. Everything is signed. That means both of them support both positive and negative numbers. Okay, they support both positive and negative numbers. If you look at byte type of data, the range for this is minus 128 to 127. Minus 128, 0. Then up to how much it is? 127. Okay, it's basically 128 to 127, including 0. This is the range. Lower range is here, minus 128. Then upper is here, 127. Lower boundary is minus 128. Upper boundary is 127. This is the range. So range for this is here. It's minus 120 is the lowest number in a byte you can have, whereas 127 is going to be the highest number in the byte you can have. So this is neither, it is signed integer, but in integer again subtype is here byte. Okay, you can store 1 byte of data in that. Similarly, you can go with the short integer. When we talk about short, here it is total 2 bytes it uses. So that is minus 32,768 to 32,767. This is the range for short. So short and short integer, they are same. Okay, a short type can hold values from minus 32,768 to 32,767, including 0. So when it is int, it's actually much bigger in range. Okay, the range for this is minus 2,147,384,000. Okay, some xx minus 1 to the range here it is 2,147,384,000, then xx, like this you have. So this is the range. Sorry, this is x here, and here I should write minus 1. Okay, this is the range for the integers. In the same way, if you go with the long type of data, it is very, very big. Okay, very big numbers you can have in the long type of data. So the integer types in the Java are very simple types. You don't have any concept called unsigned. Everything is signed only. Unsigned meaning is they support only 0 and positive numbers. In the C, you have signed as well as unsigned. But in the Java, you don't have that. Okay, it is only simple system. It is all integers are signed in Java. All integers are signed in the Java language. Okay, so this is here much bigger range of numbers. We have in the long type of data. Okay, so this comes under value type. The next type of data, we have floating type of data. One is float, other one is double. Float is basically single precision. Float first of all uses here 4 bytes. This uses 4 bytes. Okay, after decimal point, okay, this supports up to 6 or 7 digits precision. 6 or 7 digits precision. Okay, so up to that it supports the precision. This is float type of data. That means you can hold numbers like here 1.25, like this you can have in this. So this is float type of data. Okay, in the same way you have double type of data. This requires 8 bytes. Okay, this requires 8 bytes of space. After decimal point, this supports up to 15 digit precision. Okay, so if you look at the 8 bytes after decimal point, so this is decimal point basically. After decimal point, this supports up to 15 digits precision. Up to 15 digits precision you have in this. Okay, this is the double type of data. Float is single precision, double is double precision. Up to 15 digits after the decimal point it supports. After that there is no guarantee. If you look at 22 by 7, so when you divide 22 by 7, you get 3.14, some odd number you get. So in that particular number, if you take it as float type of data, that's going to support up to 6 or 7 digits precision after decimal point. After that, there is no guarantee. But if you take it as a double type of data, up to 15 digits, you can have the precision. So this is very much needed when you go with the scientific applications. Okay, scientific applications, the precision is very much important after the decimal point. Okay, but for business applications, this is quite sufficient. Okay, even if you have up to 4 digits, that is enough because Chinese and we take a standard. So, I mean, if you go with currency kind of thing, something like 10,000 yen is equal to $1, something like that you have. So therefore, if you take the double type of data, float type of data, it's quite sufficient to handle the money transactions. So these are what exactly numeric types of data. A byte, short, int, long, then float and double. Okay, so here you have integral types as well as floating type of data. So in the integers, byte type of data, short, int, long, and if you go with the floating type of data, float and double. Okay, these are the 6 types you have in the numeric types. The next thing here is character type of data. Character type of data requires here 2 bytes. Okay, this requires 2 bytes of space. This requires here 2 bytes of space. And this is what UTF-8. It is Unicode compliant. So you can have here ASCII and extended characters. Okay, you have ASCII followed by extended characters. So that is here Unicode compliant. Character is here UTF-8. So UTF-8 stands for Unicode Transformation Format. Okay, so either it may use 1 byte or 2 bytes or 3 bytes or 4 bytes depending on the data available there. It supports not only English, it supports even other languages. Like Hindi, it supports. Okay, you take Chinese, Japanese, and Korean, we call it as CGK. It supports it. It supports actually Arabic languages. And whatever languages are written and spoken these days, they are supported by the Unicode format. A character uses 2 bytes of space in the Java. Okay, but in C language, it uses just 1 byte. Okay, when you work with the Java, character type of data needs here 2 bytes of space. To store a character, we need here 2 bytes of a space. Okay, similarly, what you can do, you can cast an integer, short integer to here a character type of data, and character can be casted to a like integer type of data. You can interchange. So you can interchange the data between character and short integer to character. You can do it. Internally, characters are nothing but numbers. Okay, in the form of numbers only. Internal representation of characters is nothing but internally they are numbers. So char requires here 2 bytes of space. Okay. Then similarly, we have one more type of data called as Boolean type of data. So Boolean requires here 1 byte of space, 1 byte. Then here in this you store either true or false value. Either true or false values we store. So this is here Boolean type of data, and all these like 6 plus 7 plus 8 predefined types or primitive types or value types. Okay, these are called as value types. Let me show you, in a paint, a large paint here, and I show in the paint what is reference type and what is here like reference type and what is the value type. So first of all, here I go with the value type. Okay, so first what we do, I declare here a variable int x. When I write like this int x, what happens exactly? Somewhere for a memory location, a name is assigned that is called an x. Okay, in a computer memory, somewhere for some register, the name x is given and it is going to be remembered by your Java program. Java program is remembering the name as here x. So here int x, this is nothing but a variable we are declaring. Okay, when you declare a variable, name is only meant for our convenience. When you say x, you understand the variable name as x. It's only for our convenience. But computer exactly requires some address for that. Okay, some address is required. So address may be something like something like here, some arbitrary address I'm giving. So the address may be, okay. So address may be something like this here. So address is say some 20,000. This is the address. It is the register number in the memory. Okay. So X is referring here the 2000 address. X is referring here the 20,000 address. In the same address itself, we save the value. Okay. So here itself you store value. Value you may type as something 100. In the same location, in the 20,000 location, you are storing the 100. So that's why this is called as here value type. In the value type, what happens? In whatever location, for whatever location you have variable name, so in the same location, the data is stored. It is not stored in the different location. So this is called as value type. The location is what here? 20,000 for X. Okay, when you assign X equal to 100, what happens? In the location 20,000, 100 is going to be like kept. The location 20,000 is going to contain a value 100. So this is a value type. Now let us come to reference type. Okay, let us come to this time a reference type. So what I do here, I just declare something like here, string some S. I am defining a variable called here string followed by X. Sorry, S. So string is exactly a reference type of data. Here we are declaring a reference variable. Just we are declaring a reference variable called S. It has to point to some other location. When you declare a variable int X, something, string S, something similar to int X, it is going to have a location. Okay, let me even draw a pointer like this. Then here I want to put some location name. It is say some 30,000. Location is here how much? 30,000. String S location is 30,000. So a name we are giving to location 30,000. So its location is what exactly? S. Okay, the name of the location is here nothing but S. But here you are not going to contain data. Okay, so you have a text something like this. Okay, you're creating an object called something like here, welcome. Okay, welcome to Java. Like this, you're specifying. So this is exactly what welcome to Java. This is the value you have in the given address. Sorry, this is the value you have in the given address. But what is this address? It has an address also. Probably this is going to be here 40,000. So now what happens? This is actually in the 30,000 location. What value you have here? You are going to have this one as like 40,000. Okay, in the location 30,000, you have a value called 40,000, and using that 40,000, we reach welcome to Java. Okay, so this is what exactly? This is the location name, and the value in this location is here 40,000. That means it is referring this location. So if it's a reference type of data, okay, if it's a reference type of data, so that particular variable S is actually located somewhere in the 30,000. That is not going to contain actual value. It is going to contain the address of some other object. So welcome to Java is nothing but object here. So this object is located in the location 40,000, and using 30,000, you are going to point to the location 40,000. So this is called as here a reference variable. Okay, so from 40,000, you are going to point to 40,000 here like this. That means what? In the location 30,000, you have a value 40,000. Suppose later on you create some another string object. In that case, what happens? Its location is going to change again. So here what you do? S equal to, write this as now hello, something like this you are keeping. Now what happens in such cases? Hello is going to have some other variable, other location now. Suppose we have here, it is in the location something like 50,000. Assume like this. Location is 50,000. Here you have the data hello. Okay, this is basically hello. But if you come to the here S, what happens? You have an address for this. So what is the address for this now? This is 50,000. In this case, now this is referring the 50,000. That means the value in the S is going to change. Earlier, whatever we have, that is discarded, and that becomes actually orphan. Okay, or garbage. When it is referring this, it's not 50,000. Sorry. So this has to be not 50,000. 1 minute. This has to be something. Yes, correct. Okay. So now what is happening in this case? This is having here 50,000. So in the S, instead of having 40,000, now you have 50,000. S location is exactly 30,000. So here you have a 40,000 value. With the help of that, you reach the welcome to Java. Okay, but when you change here, when you write S equal to hello, hello is getting defined in the location 50,000. Now what happens here? in the location of the 30,000, instead of having 40,000, now you have 50,000. So like this, what is happening? It is referring some other object. So when it is referring some other object, what happens? This object becomes orphan object, and this is called as garbage. So you have garbage collection in the case of Java. Automatically, garbage is collected. So if it is not collected, if it is remaining in the memory, what happens? You cannot use it. Still, you don't have enough memory. So if such garbages are getting piled up, after some time, your system may crash. It is called as basically memory leak. That is called as memory leak. So memory can be getting memory. That's called as basically memory leak. So when memory is leaking, what happens? For other parts of the application, the computer cannot find enough memory. Either it may run slow or it may crash. So that's why we have to see carefully that whatever objects which are not referenced have to be removed from memory. So Java has inbuilt mechanism called garbage collection. With the help of that, the unreferenced objects can be removed. So this is basically reference type of data. You have value type and you have reference type. So now this 50,000 is referring this one. So in the address of the 30,000, now you have 50,000. So using 50,000, this time it is reaching now this location. Okay, it's reaching this location. So here in the place of 40,000, I select it. Now I can put this as here 50,000. I can take this value. Okay, again I take this here, I cut it. And in the place of 30,000, now what value we have here? 50,000 we have. Okay, this is going to be, sorry, this. Yeah, this is going to be now 50,000. So like this, what happens here? The location is getting changed. Now this is referring this location. This time, now it is coming to 50,000 here. In this location, you have hello. So 40,000 and 50,000, in these locations, you have objects. Initially, you have welcome to Java, that's one object, and here hello is another object. But using same reference variable, you are accessing initially with the 40,000, then you are going with the 50,000. When you start accessing the location 50,000, you are going to lose reference to 40,000. Therefore, what happens with that? This becomes an orphan that has to be cleared. So using garbage collection in the Java, we can clear that. So like this, you have value types as well as reference types. Okay, so now when we come to this, here, these are called as primitive types. These are called as primitive types. And one more type of value type is enum. So enum is going to contain user-defined constants. Multiple values you have in that, and whatever value you want to assign to enum variable, you can assign. The enum can be declared like this. Enum followed by, like, go with the weekday. In the weekday, you can define something like this. So here you can take Sunday. Okay, we call it as Sunday. Then Monday. So this way you can assign something. So up to Saturday you can take. So this is containing here some constants. Sunday is a constant, Monday is a constant, Tuesday, Wednesday, Thursday, Friday, Saturday, you have 7 constants. But from that you can use only one value. So this is called an enumeration. This is again value type of data, but this is user defined. As per the requirement of the user can define this type of data. So here numbers, that is integers, floating type of data, character data, Boolean type of data, enum. So these are basically primitive types. But all these they inherit from the Java object. On the top of the type system, we have a class called object. Every type, whether it is value type or whether it is reference type, they inherit from the object class. They are going to be inheriting from the object class. So from object class, again, you have 2 different types. One is value type, other one is reference type. So the value types are here, like character type of data, integer type of data, floating type of data, similarly Boolean type of data, and other one is user defined type of data. Okay, whereas string is what? String is called as reference type of data. String is called as reference type of data. So it is different from the primitive types. So there is a lot of overhead involved in the case of string. Okay, so using string class, you can create the string object. Once you create string object, you can perform various operations on the string object. It contains various methods. Now let us try to write a program with this. Okay, using this type of data, let us try to write a program here. So just Let me open the Eclipse here. In this, I create a new project called Java types. Java data types. Project name itself is Java data types. Okay. Then here, go with the next. Then here, don't check this particular thing here. Whenever you are creating, okay, if you come back here, do not go with the create module info Java file. Never create this. Never check this. Okay. So why you should not check right now? Later on, I'll tell you how to create this module info file. So right now, don't use this. Click on the next here. Then here, go with the finish. Okay. Now the new project is going to be here Java data types. And in this, we have a SRC folder, we have a bin folder, and one more thing is here JRE system library. It is Java runtime environment system library is available in this. Okay, now come to SRC folder, try to create here a new class. Go here and try to create a class called, here it is, Java types. Class name is also, I want to name it as Java types. And this should contain here a main method. A main method is nothing but starting point of the application. Okay, click on the finish here. Now, here, this is going to be a default package, or if you want to define your package type, you can define package, then write Java types. Okay, Java types. This is the name of the package. Okay. So package, let us go here and try to type some XYZ. Okay. So we need to have a folder. In that folder, you should have it. Since this is not available, you have an error here. So just come to default package, try to rename this. There's a possibility to rename this. Okay, export, import you have here, run as you have. So properties, here it is Java types SRC. Okay, so the package was not defined. Therefore, come to this class or go with the properties in this case. Java editor, Java doc location, Java compiler, resource, let us take. Okay, coverage, build path. You take here source, then this is projects, libraries. Okay, module dependencies, you don't have anything, just cancel this. Now let me delete the class here. So just go to this, delete here. You can delete it, continue. Now here, once again, let us try to create here a new class. This is a class, name it as Java types. Okay, then you need to have your package name. Call it as Java types. Name of the package. It's going to create automatically folder for us. Click on the public static void main, then finish. Now what happened here? It has created a new package called Java types. Okay, it has created new folder. So the folder name is Java types. Within that, now we have the required class. Okay, so in this, let us try to experiment with numbers. Now what I do, first of all, I declare here something like int a equal to 100. Then I write here b equal to 200. I can declare a variable and I can assign at the same time. So int a How much I assigned value? 100 I assigned. Here B equal to 200 I assigned. Both of them are integer type of data. Okay, both of them are integer type of data. So what type of data it prints? Let us see here. Now system dot out dot println. Here we go with the println. Then here let us type it as a dot. Okay, so any provision do we have here to print a dot? We don't have anything. Okay, then go here with the class dot. Okay, so class dot we don't have anything. Then try to use here type of. Then try to give here x. Okay. Sorry, we don't have any x. This must be a here. So go with the a. Not x. I did not have any variable called x. It is just a. But if you look at this type of, okay, create method type of. So this method is not available here. This method is not available for us. So therefore, okay, don't do anything here. Time being, what we do, we just try to declare another variable int c equal to, okay, I just go with some calculations here. System dot, then out dot println. Then here try to print a plus b. Okay, I want to print here a plus b. Then I want to print here a minus b. Go with this, then print here a minus b. Here this is a minus b. Then a multiplied with b. In the same way, you have here a divided with b. So what result normally we expect here? We expect this one as some 300. Okay, this as here minus 100 and this is here 20,000. Okay, and here we expect it as something like 0.5 something you need to get. Okay, but what result we get? See in this when we run. So just go here and try to run this. You are getting the result as 0. Okay, why we are getting result 0? In Java, in a arithmetic operation, if both operands are integers, so you take an expression here, arithmetic expression, a divided by b. A is here a variable and b is another variable. A is integer type of data, b is also integer type of data. When both the integers are part of an expression, when the expression evaluates, you are going to get only the integer, not the floating point number. When you divide 100 with 200, you expect it to be something like 0.5. But what is happening here? We are not getting it as 0.5, rather we are getting 0. When you divide 100 with 200, definitely you get 0 if it is integer. But if you want to get floating point number, one of the numbers must be floating point number. Then in such cases, you are going to get correct result. Now let me come to this point and here multiply this with the 1.0. So when I multiply that with the 1.0, what do I get? See in this. So still you are getting 0.0 only. Here, still you are getting 0.0. But when you divide A with B, what result normally we expect? What result we have to expect in that case? A is 100 and when you divide 100 with 200, so it is 1/2 you get. 1/2 is nothing but here 0.5 you should get. Okay, so when you go with that, this must be here like 0.5. Here again, precedence comes into scenario. So try to put in the brackets here, this one. Try to put in the brackets, then what result you get? See in this. Now you are getting 0.5. Okay, you are getting now 0.5. So here following BODMAS rule is very, very important. So this is part of mathematics, brackets of division, multiplication, addition, and subtraction. Okay, So if you don't put here these brackets, what happens? First of all, A is getting divided with B, which you get as 0. When you multiply 0 with 1.0, you get 0. It's going to be 0.0. So what happens here exactly? Here, when you divide A with B and A is integer, B is integer. If you don't multiply B with 1.0, what will happen there? You get it as 0. Okay, now also same thing is happening, but you are getting floating point number. Again, if you run here, you can see the result. Okay, you can see the result, you get 0.0 because you have a precedence of like for division, you have highest precedence over multiplication. So first division is performed, then it goes with the multiplication. So therefore here you have that problem. So in such cases, if you put in the brackets this one, what will happen? You are getting the size here 0.5. Okay, you can get the size here 0.5. So when you work with arithmetic operations, you have to see, you have to properly write the expressions. Wherever required, you need to put the grouping symbols. Grouping symbol is nothing but here, the parenthesis is nothing but here, grouping symbol. So using that, you need to group the elements. You're dividing here A, then you are writing within the parenthesis B multiplied with 1.0. Okay, so this is exactly like you're getting the result, expected result you are getting now as 0.5. So here it is following BODMAS rule. But when you work with the JavaScript, you don't have this problem. Always you have only one type of system that is called as number in the JavaScript. So that only contains both integers, floating point of data, floating point data, complex type of data, everything is in the same number. So here integers are different, floating type of data is different. So when you have in an expression only integers, the result is going to be only integer. But if any one of the operand is actually floating type of data, result can be floating type of data. So whenever you write expressions, you have to take care of this particular thing. Okay, when all the operands are integers, result is going to be integer of the given expression in Java. Okay, but if any one of the operand in the given expression is floating type of data, result can be floating type of data. So if you look at the line number 10, we have written there A plus B. A is here integer, B is integer. In the next one, you have A minus B. A is integer, B is also integer. When you come to the third one, you have A integer, B is also integer. You are multiplying A with B. When it comes to here, the last one, so here in the line number 13, it is you are dividing A, first you multiply B with 1.0, then whatever result you get, with that you are going to divide the A there. So therefore you get it as 0.5. So like this is going to work for you. Okay, it's going to be working like this for us. So next thing, we look into floating type of data. Okay, we look into floating type of data. Suppose if I define here float, say some x equal to, if I put something like 10.2, 10.3, this is going to be error for us. Why this is error? 10.3 is basically double type of data. Default type of data, when you put something in the like in the floating point notation, that is going to be double type of data. So to make it floating type of data, you have to use actually f as a prefix, suffix. You are making it as float type of data. Float x equal to 10.3 f. But if you don't f, it is going to take automatically double type of data. Now let us come to this point here, double. Then right here, pi equal to 3.14. So exactly the pi is what type of data for us? It is now double type of data. It is here double type of data. You get a value as here 3.14. Okay, but if you omit the f and if you try to assign a value, it is not going to accept. Why it does not accept? Reason is x is lower type and double is higher type. X is lower type and here the 10.3f is what? Higher 10.3 is higher type. That means double type and x is what here? Float, which is lower type. So when you try to assign a lower type, higher type value to a lower type value, it does not accept. Okay, either you have to forcefully convert or it will not work. You have to forcefully convert. That is called as typecasting. Suppose if I don't have here f, I can write like this here. Before this, I can put something like this. This is called as typecasting. So forcefully you can convert that. Okay, forcefully you can convert that. There are two concepts in this. One is here widening. The next one is narrowing. Okay, there's a concept called widening and narrowing. For example, you have here byte b equal to byte sum x1 equal to you have some 100. Okay, next what you do here you are going to, okay, we are not using it, fine. Next I write here IAT x2 equal to, here this is like some x2 equal to, when I write x1, there is no problem in this because 100 can be converted to integer type of data. For 100, how many bytes they are using? 1 byte. 1 byte data can be accommodated in 4 bytes. Okay, you take 1 byte of data that can be accommodated in 4 bytes of data. For example, you take 2 buckets. One is 4-liter bucket, other one is 2-liter bucket. Okay, one is 4-liter bucket, other one is 2-liter bucket. You assume that there is full of water in the 2-liter bucket. Okay, without losing a single drop of water, you can take the water from 2-liter bucket and you can put in the 4-liter bucket. You don't lose any data in that case. But you have here a bucket full of water in the 4-liter bucket. Full of water in the 4-liter bucket. So if you want to put the water from the 4-liter bucket into 2-liter bucket, it's not possible. Some of the water will be lost in the form of the overflowing. Same thing here it is. So if you look at byte x1 equal to 100, by int x2 equal to x1, when you write, data from x1 can be, stored easily with the x2, because x2 is actually bigger type, and here here x1 is lower type. Lower type is using only few bytes when compared with the higher type or bigger type. So x2 is having 4 bytes. So accommodating one byte of data in 4 bytes is easy. So this is called as here widening conversion. This concept is called as here widening conversion. Automatically, this is getting widened. Okay, so this is called as here widening conversion. Okay, next, what you write here? I write this way, int some x3 equal to, okay, int x3 equal to, I put some 500. Now, if I try to write x1 equal to x3, this will not accept, because this is called as here narrowing conversion. It is called as here narrowing conversion. Reason, here x3 is using 4 bytes of space. x1 is having here only 1 byte of space. If you try to assign data of the x3 into x1, it's not possible here, because basically the data which you have in the x3 requires here 4 bytes. But here what is happening? You just have here only 1 byte. So because of that, here it is unable to accommodate. So therefore, it is nothing but here error, and here this is called as narrowing conversion. Okay, narrowing conversion has to take place here. So for that purpose, here you need to put like casting. So you can put a casting like this byte you put. You are converting the x3 data into now x1. But in this process, what happens? You are going to lose some data. Data is going to be lost in such cases. Okay, so this is called as here narrowing conversion. Okay. So here we are forcefully converting x3 into byte. So in this process, what happens? Some of the data you may lose. This concept is called as here narrowing conversion. So conversion can be widening. Widening happens automatically, but narrowing conversion will not happen. So using typecasting mechanism, okay, typecasting is nothing but you specify the type of data into which you want to convert the data in the parenthesis. After that, you have here the variable name x3. Now, whatever data you have in the X3, it is actually stored in the X1, but in that process, there is no guarantee that you have the exact data in the X1. You may lose some of the data. So this is widen narrowing conversion, and this is called as here underflow. So you don't have exact data in that. Now let us try to print what data we have in that. So just go with the system dot out dot println. Okay, system dot out dot println. Let us try to print here the values of, first thing is we go here with the byte type of data x1. Similarly, we go here with the x1 we print. The next thing is here we go with the system dot out dot println. Similarly, this is here like we go with the x3. Okay, before, yeah, now what result you get? Initially, we had x1 equal to 100. Okay, initially we have x1 equal to 100. Let us print again the x1 value here at the top. Before we do anything, let us try to print this. So the result is exactly what? First, it has to print for us 300, then minus 100, then 20,000, and you should get here 0.5. Okay, then after that, what exactly we do? We print the value of x1. So 100 must be getting printed for us. Okay, then here once again, it has to print 100, but it will not print 100 because we are forcefully converting x3 into x1. That means the value in the x3, whatever you have, that is forcefully kept in the x1. So x3 size is 4 bytes, x1 size is 1 byte. So what happens? Some of the data you are going to lose when you go with the narrowing conversion. Okay, some of the data you are going to lose. So what type of data we are going to get in this C? Now let us run this and see here result. So let me clear here this one, then try to run this here. Okay, what is happening? We got initially, so initially what we got? So first thing is 300 with this, second thing is minus 100, then we have 20,000. With this calculation, we get 20,000. Okay, then you are getting here 0.5 with this. So with this, you get 0.5. Then here we have declared x1 equal to 100. Then we are trying to print the value of x1. So later on, what we do, forcefully we are converting the 500 into x1. So what happens in that case? You are getting value as minus 12. You are getting the value as here minus 12. Okay. Then after that, what happens? It is going to, like now when you take this here, x1 equal to x3. After that, you are printing x3. No change in the x3, but in the x1, you have a value which is truncated. Exactly, you can't have here the value of x3, but what is happening? Data is getting truncated. You have here a value like minus 12. So you lose data whenever you go with the typecasting. So there are two types of conversions. One is widening conversion, other one is narrowing conversion. In the widening conversion, automatically the type is getting expanded. Okay, lower type is getting expanded to higher type. There is no problem in that. X1 is what type of data? Byte type of data. X2 is what here? Integer. Okay, 1 byte data easily you can say with the 4 bytes data. But if you take 4 bytes data and you try to say with the 1 byte, it's not possible. As I told just now, 4 liters of water cannot be stored in 1 liter bucket. Okay, there are two buckets. One is actually 2-liter bucket, other one is 4-liter bucket. 4-liter bucket is full of water. You want to transform all this water into 2-liter bucket. So it will not be happening there. You are going to lose some water from that. So same thing is happening when you try to assign x3 to x1. So this concept is called as narrowing conversion. One is widening. Widening automatically happens. You did not do any, you did not handle in any way. But when it is narrowing conversion, you need to typecast. So if you don't typecast, what happens here? It gives error for you. You get this as error. Okay, when you try to assign, this is giving error. So this concept is by forcefully converting it, you can do it. So for that, you have to use here the typecasting mechanism, call it as here byte, because x1 is byte type of data. Okay, before that number, which is in the right side. So what you do, you write in the parenthesis the byte. So this is called as typecasting. So using typecasting mechanism, you can convert it. So this is here narrowing conversion. So this is basically integer types of data, numeric types of data we are working. Okay, so in this we saw like how arithmetic operations are getting here evaluated. Okay, and when both the operands are integers, result is always integer. But if any one of the operand is here floating type of data, it is going to be evaluating to float type of data. So these points we need to remember whenever you perform any arithmetic operations. Next thing is what? Widening conversion, and other thing is narrowing conversion we have seen. So these are numeric types of data. Now let us look into next type is here character type of data. Okay, so character type of data that supports Unicode characters. It supports basically Unicode. So Unicode is nothing but it is a character set in which you can use characters of all the languages which are used in these days in the world, both for writing and reading purpose, whatever languages are used. So they can be used in the data. Just a minute, please. Hello, Srinivas sir. Hello, Srinivas sir. Okay, okay. Yes. Okay. So character type of data in the Java is Unicode. It's not ASCII. If you look at language like C, it is basically ASCII. So ASCII is nothing but American Standard Code for Information Interchange. This uses only 1 byte. Okay, the range for this data is you have ASCII numbers 0 to 255. So total 256. For 256 numbers, we have the codes, equivalent codes. So in this, for example, take digits. 0 is equal to number 48. Similarly, 1 is equal to, it is 49. Okay. And other thing is 2 is equal to here 50 and so on. Last digit 9 is going to be equal to here 57. So these are for the numeric numbers or digits. Similarly, you take uppercase alphabet A, which is equal to 65. So uppercase G you take, this is equal to 90. Lowercase a you take, this is 97. And similarly here, lowercase z, this is equal to 122. Like this, for all the characters which you see on the keyboard, you have equivalent numbers. So that is called as ASCII code. Okay, it has basic character set as well as extended character set. You have two character sets in that. One is basic, other one is extended character set. So this is basically ASCII. But sometimes what happens, we have to use even other languages. Like you see, for example, you want to write something in the Chinese language or Japanese language or Korean language. So that basically is called as CJK, Chinese, Japanese, and Korean. Okay, these are Far East languages. So they are ideographic languages. They don't have too many characters, just something like in the pictorial form, they try to represent. So they are called as ideographic characters. So they are not supported in the ASCII. So for that purpose, this has been extended. That is called as Unicode, universal code it is. Similarly, like if you take Gulf countries, they speak their Arabic language and they write in the Arabic. So for them also we require like character set. So that is supported in the Unicode. But they are written from right to left. Unlike left to right, they are written from the right to left. And our Urdu also is written from right to left. Okay, they're written from right to left Urdu. So why I'm saying our? Because Urdu was born in Hyderabad basically. Okay, it was born in Hyderabad and it was actually grown. It grown in the Lucknow city. Then after that, it has become famous. mostly the Pakistan and Bangladesh, not in even Bangladesh. In Pakistan, that is widely used. Their official language is Urdu language. It's really beautiful language if you understand it. Okay, so you take Urdu, or you take Persian languages, or you take Arabic languages. They are called as basically Arabic or Arabic-like. They are written from right to left. Similarly, you have our Devanagari Lipi, like Sanskrit, or you take Telugu, Tamil. Okay, so all these are written. For them also you have character set. So all of them are accommodated in the Unicode. So that's why Java character uses here 2 bytes. It's going to use 2 bytes, and this is now UTF-8 compliant. Unicode transformation format 8, that is called as. Okay, UTF-8 compliant, that is. So character set, using the character set now, you can represent whatever languages are written in the world now. For all the languages, you have here characters available in the Unicode. In the web, mostly that is used. Now let us see how ASCII characters are. What I do here, I just declare a variable called int a equal to 32. Okay, then I try to, sorry, a is already defined. Then I write this as ch here. Ch equal to 32. I want to print all these things. For the sake of this one, I try to use a loop. Okay, int ch equal to 32. When you write, I want to use here some loop with the help of loop. What is loop? Later on we understand. But in a loop, I'm trying to print it. Ch less than or equal to 255. Then I want to print something here. So come to this point here, then system dot out dot, then write this print. I don't use this time println, just I use print here followed by ch. Okay, I am trying to print something like this, but ch, if I try to print, it's going to print here 32, 33 like that. But I want to convert this into character, which I can do using typecasting mechanism. I can use here chr. With the help of that, it can be getting printed. Okay, then put here, after that increment ch plus plus using increment operator, we can do it. Now when we run it, it's going to print all the printable characters from the ASCII. They start from the 32. 32 is nothing but space. After that, whatever characters we have, it is going to show us here. You can see here all the characters are getting printed in the bottom of the screen. If you see, you can see all the characters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, all the things are coming here, lowercase alphabets as well. Then you have here, this is extended character set of ASCII. In this, you find some of the characters which are used in the French language, German language, Russian language, Spanish language, okay, in Latin. So all these are coming in this. Apart from that, you have certain mathematical symbols in this. So this is called as here extended character set. Okay, this is nothing but extended character set. So together it is showing for us. So you can print characters. That means whatever you see on the screen as a symbol, it has a numerical representation in the computer. So ch equal to 32. I'm trying to print all the ASCII characters from 32 to 255. Last one is 255. So here they have written a while loop, while ch less than or equal to 255. Then system.out.print character ch, char ch, then ch plus plus. So initially it prints 32 value, then increments to 33, then prints it again 34, 35. As long as ch value is less than or equal to 255, the loop continues. But once it becomes 256, you come out from the loop. So like this, you can print all the characters. So this is basically called as Unicode type of data. It supports the Unicode characters as well. Okay, our Indian characters it supports, but we need to know the Unicode value for that. If you know Unicode value, that can be getting printed there. So for that, we need to check in the internet what is the Unicode value of the Indian rupee. Okay, so take this Unicode value for Indian rupee. So Indian currency you have, let us see that. So this is 8377 is the value, but whether it is going to print or not, let us see. 8377 is the value for Unicode. Then next here I assign ch equal to 8377. This is the number I'm trying to assign here. Now let me print again this character. Okay, go here, then try to print ch. This should print the rupee symbol. whether it's supporting or not. In the web it supports, but here it's supporting or not, we can see. You are getting rupee symbol. Okay. So here what I do, just type system dot out dot println. Okay, then here it is just slash and I put. I'm going to here put a new line. Okay, just I take print at the end of that, instead of printing at the end of the existing characters, I go here with the new line character. With it, you can come into next line. Just try to run again this here. So you're getting rupee symbol. You can see here rupee symbol. Okay, so similarly, let us try to see here for Telugu Telugu alphabets otherwise. Okay, alphabets. So this is A is the value for this. Okay, let us try to get the value here. Somewhere you can find the entire so Telugu letter, this is 0C05 Telugu Unicode block. From this you can find. Okay, what is the numeric value for that? Let us try to find here. So this is 3077. Let us try to print that value. This is here C3077, and let us try to print it. So here next CH equal to, we take this and try to assign a value 3077. Once again, let us try to print. Here I use the println then. Okay, println I use, even if I don't use println, no issue. Okay, side by side, this is going to be getting printed for us. So come to this point and here print it. Now just try to run this here. You can see here A is getting printed. What is getting printed here? A is getting printed. So like this, using Unicode, you can represent different characters. Okay, let us see any Urdu word, any Urdu alphabet. Unicode value for Urdu alphabets. Okay, Urdu alphabets. So this is the range for Urdu alphabet. Okay. So there are 46 alphabets not here. Okay. This is 6050, but 64,000 only it supports. But if you try to assign the value, you will not get that, because range actually, okay, it's 65,000. Like, let us try whether this comes or not here. See this. Okay, 535. So this should print actually the Urdu character for us now. So undo this one here. Let it be like this, no issue. But here we take CH equal to next one. We put this, then try to print again the Urdu alphabet. Okay, take this, try to print here. What result we get? See this. It is printing the Urdu alphabet. You can see here. So it's printing here Urdu alphabet. So Unicode is therefore basically supports here all the languages which are written these days in the world. Okay, so you can represent any language with the help of the Unicode. And next type of data is here Boolean type of data. Okay, so to declare Boolean type of data variable, you write here Boolean followed by Boolean right here, then B equal to, not B, is true equal to, you can write it as false. So this way you can make it. You can assign a constant either true or false. The variable is what here is true. Is true equal to false I have written. Okay. Or else what I can do, I can declare a variable this way, Boolean, then here is greater. Is greater equal to, I can write it as 10 greater than 20. I can create a expression like 10 greater than 20. If 10 is greater than 20, then that's going to be true. Otherwise, it's going to be false. Let us try to print it. So system dot, then out dot println. Then here, try to print this one is greater. What value it prints? Let us see this. Let us try to print here. what value it prints. So after this Urdu alphabet, now you get it. Just go here and try to run. It is printing this as false because 10 cannot be greater than 20. So 10 is always less than 20. So using relational operators, we are forming an expression. It is comparing the left operand with the right operand. So if the left operand is greater than right operand, in such case, that is going to be true. Otherwise, it's going to be false here. So we are getting the false. This is correct only. Expression is getting evaluated to false here. So like this, we use the primitive types of data. One is what? Numbers. The second thing is character type of data. And third one is Boolean type of data. So these are primitives, and Java type system is very, very simple. Okay, it's very simple type system. Okay, unlike actually like C or C sharp, you take other languages, there is a lot of confusion in that. Like unsigned type of data, signed type of data, you have so many variations in that. So fortunately, we don't have in Java that particular system. Wantedly, they made it simple. So Java type system is very, very simple. We have two types of data. One is value type, other one is reference type. Okay. Any questions on this?